Alright, hopefully this is already up and streaming here. We're going to be continuing some Spark fundamentals this day. We're going to be going over Boolean column expressions first. I hope that some of these useful functions will be helpful for you all during your project. So we're just going to go ahead and jump in here. So first, of course, we're going to go ahead and initialize our Spark session. First, using our Spark context and passing the Spark context to our Spark session. So we're going to be continuing with this car database that we were using in the past 2 weeks. So here I'm just loading my CSV file, empty cars. We're going to infer the schema and keep headers equal true so that we maintain those column names. Here, empty cars with column renamed, because the first column actually was given a default value of underscore C0, I'm replacing that now with the name model. And when we run that, we should get our data frame back with the first column renamed as we defined. As you can see, it worked. We have our model and all of the various values associated with each car. Alright, so the between method. What we're going to do here is it's going to return a range of values which we specify with the argument. So here we're going to look for the cars with the cylinders between 4 and 6, and it's as easy as saying empty cars dot cylinder, specifying the cylinder column, and then we call the between method, providing the values that we are looking for within that range. So one thing to note here is, unlike Python slicing, it does in fact include that second argument. So it will return values that have 6 cylinders. Okay, so now that we have our MPG between, which is a slice of the data frame returning the matches upon which we define with our between method, when we now select the cylinders, providing MPG between, and then we're going to show 5 of them, we can see here that it's a Boolean that's returned, true or false. So we can see that this one is 6 is true, 6 true, and so on. So now we're going to look at the contains method. Contains is more for dealing with non-numerical data, so strings and dates and so on. So here we're going to say empty cars.model.contains HO. So should return any car that contains the letters H and O within the model. So when we run that, we can see that we're only returning the first 5, given we called .show 5. And here we see that Mazda RX-4 returns a false, Mazda RX-4 wagon equals false, and so on. Here we have the Hornet and the Hornet Sportabout returning true because it does in fact contain HO, which is what we were looking for. If we were to change this to say MAZ Mazda, when we return that, we can see that now in fact the Mazdas do return true. So this is very useful if you're trying to filter your data set and only return information that you are interested in. Okay, so ends with. It's pretty self-explanatory. What we're going to be looking for is the models that end with the letter T. So here we're just going to go ahead and make a new variable called model ends with. We're going to say that that equals empty cars dot model dot ends with the letter T. So we're going to look for cars whose model name ends with the letter T. So we're going to select the cars from empty cars, the model. We're going to pass in this filter that we defined here, and then we're going to go ahead and show 6 of them. So we can see here that all of the models that don't end with T return a false. The ones that do return true. Here we have the isNotNull method. So when you're going through your data, trying to make sure that there aren't values in there that won't provide any meaningful analysis, it is wise to go ahead and check for nulls. So this may be helpful for you. Here we're going to have to import row from the PySpark.sql library. Here we say df equals spark.createDataFrame. The row name equals Tom, height equals 80, and then we provide another row. We say the name is Alice and the height is equal to none. So we're just creating a null value. So here to do a comparison to see if the values are null or not, we can now use this df we created. We're going to say the df dot height dot is not null. When we do a select, honing in on the height, we provide the height is not null filter. When we show that, we see what is returned are Boolean values indicating if the value is null or not. And here we have the opposite, is null. So here we're going to go ahead and say df.height.isNull. And when we go ahead and do our select, providing the height as the first argument, providing that filter that we defined using the isNull as the second, what's returned now is 2 columns. We have the height, and then we have our height is null, which is a Boolean indicating if it's null or not. Okay, so is in. It's a true false if the column value is contained by the evaluated argument. So carb is in equals empty cars dot carb dot is in, and we provide a list. So we're checking to see if it's in 2 or 3. So very much like what we've been doing before, we're going to go ahead and do a select. We're going to hone in on the carbs. I believe that's carburetor. And then we're going to go ahead and pass in that variable which we defined up here, the empty cars.carb.isIn 2 or 3. We provide that as a second argument. And when we call .show, resulting in 10, we can see that the carburetors that have 4 return booleans of false, and the ones that actually are 2 return true. We don't have any that are 3, so we don't get any true values for anything else except for the ones that match 2. So here we have something called the like method. So it's very similar to what you've seen in SQL when you're trying to match string values where you don't exactly know exactly what the entire pattern will be. So here we're going to go ahead and say empty cars.model.like, and we're looking for models that have a name that start with HO, but we don't know exactly what they're going to be ending in. So kind of like a regular expression. we're trying to handle all possible use cases. So this may be useful for things like usernames. If you happen to store your information in the database, such as like Mr. or Miss, or possibly emails, it's very useful when working with text data. So here we're going to say mtcars.model.like HO, and we're going to provide this symbol here, which is just going to indicate characters that come after it. So it could match anything after the words or the letters HO. So we're going to do our select. We're going to hone in on the model, pass in that model-like variable which we just defined. I didn't run it. And you can see here that only the models that start with HO and then they have characters coming after it return true. Here's the R-like method. So it returns a true false if the column value matches a pattern based on SQL R-like. So it's a like with rejects. So here we're going to use a variable called model R-like equals mtcars.model.rlike, and we're going to go ahead and pass in t with a $sign. And then when we do our select, we pass in the area of interest, which in this case is the model. The second argument, we're going to go ahead and use what is kind of like our filter, only returning the true and false values. And when we return .show, we can see that only the values that contain a t in the name, a lowercase t, because you can see here that we have Toyota in uppercase, but because we passed in the lowercase t and the $sign, only the models that have the lowercase t's are going to be returned. So the difference between the R-like and the like here is that here we defined, it's pretty much, we're looking for an exact match from the start of the string. So we have HO, so this one has to start with HO. If we were to provide just T here, we would see that they all return false, where we do have a lowercase t in the Hornet Sportabout and the Valiant model. Okay, so here's the starts with. It's very similar to the example we did above with the like. So we're going to look for the models that start with Merc. So M-E-R-C, the capital M. So as you can imagine, this is most likely going to only return cars that start with the word Merc with the capital M. So this could be, you know, Mercury or something like that. So here you can see that only the cars that start with the word Merc do in fact return values. So if we were to say, change this to Hor, you can see that the Hornet values are returned, but it did not return the Honda. So we had to have an exact match with the HOR. So it's not just looking for HO, it's looking for that exact match. Okay, so now we're going to get into some more functions using the PySpark.sql.functions library. Let me go ahead and close this last session so we don't have any confusion with variable names. Okay, so we're going to go ahead and reinitialize our Spark context, then create a Spark session. Excuse me. So the PySpark.sql.functions is a collection of built-in functions for creating column expressions. These functions largely increase methods that we can use to manipulate data frame and data frame columns. There are many SQL functions from the PySpark SQL Functions module. Here we're just going to go over a few and show the ability to create column expressions. So the convention when importing this library is just to name it as F to kind of simplify the process. Okay, so this one's probably going to be pretty self-explanatory, but to find the absolute values of a column, we're going to go ahead and import row from PySpark to SQL. We're going to parallelize. We're going to say the first row is x equals 1. We're going to say the second column is -1, and the third column is -2. And then we're going to go ahead and call .2df. So we're creating a data frame with 3 different rows. Now we can go ahead and use our function library, or I'm sorry, the functions module. We're going to call f.absoluteValue, indicated here by abs. So f.abs, df.x, we're going to focus on that one column. So we can see now what's returned is a new column called, I'm sorry, I don't think we ran this one yet. So we're going to go ahead and select the df, focusing on x. We're going to go ahead and provide the second column name, xapps. When we call .show, we can see now that we have computed the absolute value for each of those columns. So concat. This is going to be a very useful one if perhaps you are working with a data set that, for example, split up the dates. So we say you had a month column, a year column, and a day column. And you wanted to join all of those together so that you can create a actual date-time object in the format of, say, 1/11/2017. So an easy way to do that would be to concatenate all of those 3 individual columns, the month, day, and year, into a single column, which you can then later convert the data type and do your analysis on. So here we're just going to go ahead, we're going to create a data frame which is going to have a few rows indicated here. We're going to say A is equal to apple, B is equal to tree. Our second row, we're going to have column A equal orange and column B equals flowers. And then we're going to go ahead and just turn that into a data frame. So now if we wanted to concatenate those 2 of those strings, we will just say AB concat, which is going to be our new column name. We say equal that to f.concat, so the function's method.concat, df.a, and df.b. So we're going to combine these 2 columns, A and B. We run that, and we go ahead and say we're going to select df.a, df.b, and ab concat. And when we show them, we can see now that the 2 strings have been joined together, and we result in apple tree and orange flowers. Sorry about this alarm, guys. I keep hastily turning it off and not actually hitting the turn off button. Sorry about that. Alright, so correlation. So very similar to the pandas.core method, we can also use this in PySpark. So here we're going to go ahead, we're going to read in our data frame that we've been using before, the mtcars, inferring the schema, and we're going to go ahead and keep the header so that we maintain our column information. So here, in order to see the correlation of the drat column and the weight column, we just simply call f.core, provide those two columns. So now what we're doing is we're comparing the drat and the weight, and we're seeing what the correlation is between those two columns. We can see here that there's a negative 0.71 correlation, indicating that there is a pretty strong negative correlation between the two. Alright, so the array method. So it creates a column expression that merges multiple column values into an array. So here we're going to say calls equals eval mtcars plus column for column in mtcar.columns. We run that, we can see now that we have each individual column that comes after this first one, the initial underscore C0, which is the model name, because we are saying here for mtcars.columns 1 forward. So index 1 forward, so that's basically all of the values afterwards. So now we have each individual column here. So if we were to go ahead and use the f.array and we provide those columns, we now see what's returned is we have an array that joins them all together, basically flattening the information. So if we want to go ahead and select these, and we use our calls array variable that we defined up there, we were going to go ahead and .show it, truncating equals false just to clean up the visibility. We can now see that the column name is in fact this entire array. But what's returned now is all of our values in individual rows. So we have the miles per gallon, the cylinders, the displacement, horsepower, and so on. So this might be very useful if you're trying to do some ETL processes and you really need to get in there and work with this data, maybe converting the data types, maybe even changing values within it. Alright, moving on now, we got two more little tutorials to go over. So user-defined functions. So you will see these widely used in PySpark. Basically, they are how PySpark allows you to create your own functions, and you simply just use the UDF method, which is part of the PySpark.SQL functions library. So we're going to go ahead, create a new Spark session. Alright, so just a little note here. The PySpark.SQL functions.udf function is a very important function. It allows us to transfer a user-defined function to a PySpark.SQL functions function, which can act on columns of a data frame. It makes data transformation much more flexible. Using UDF could be tricky. The key is to understand how to define the return type parameter. So here we're just going to go ahead and we're going to import all of the data types. And we're also going to import the UDF, user-defined function module. Here we're going to go ahead and import our CSV, keeping the columns, and then we're going to go ahead and just quickly rename that first column to model. So the structure of the schema passed to return type has to match the data structure of the return value from the user-defined function. So case 1, divide displacement by horsepower and put the result into a new column. So the user-defined function returns a float value. So here we call UDF, we pass in this user-defined function here, which we divide displacement or divide horsepower by displacement, and then we want to say set this return type here. to the type of value or the type of data type that we actually want. So here return type equals float type, and just a note, this does take camel case. So float type was imported here when we just did our PySpark.sql.types import all. Alright, so all original columns equals eval empty cars dot plus x for x in empty cars dot columns. So here we just have all of the column names as we can see up here. So the displacement by horsepower column equals displacement by HP underscore UDF. And we're going to provide empty cars.displacement and empty cars.horsepower, which are the arguments expected by our user-defined function up here. So the new columns, now when we go ahead and concatenate these by saying all original columns plus within square brackets we provide this new displacement by horsepower column. So now when we go ahead and do a select on our new data frame called all new calls, we show it, we should be able to see in our last column here our newly created column, which is displacement by horsepower. So here we're going to go ahead and create a new user-defined function that's called merge two columns. It's going to take two columns as the arguments, and we're going to return an array basically that has a float of column 1 and a float of column 2. So first we're going to convert the user-defined function into a UDF function. Simply we're going to go ahead and define our variable name, array merge two columns UDF, and we're going to say it's equal to calling the UDF module, provide merge two columns, which is our user-defined function, and we want the return type equal to an array that contains floats. So now our array column equals array merge two columns UDF, user-defined function, and then we're going to go ahead and provide the displacement and horsepower as the two arguments that are expected by our user-defined function up here. So now we're going to go ahead and concatenate all of the original columns and then our new array column. So now when we go ahead and call the dot show method on our new data frame, truncating equal false for visual to improve the visual return, we now see that we have a new column here that actually contains an array. So it's got our displacement 160.0 and our horsepower 110.0 because we defined that we want them to both be returned as a float type. Okay, so array type versus struct type. So both array type and struct type can be used to build return types for a list. The difference is array types require all elements in the list to have the same element type, while struct type can have different element types. So as you can see up here, we had to change the horsepower into a float when it originally was a integer. But struct type allows you to be a little bit more flexible on the values contained within the array. So we're going to go ahead and define an array type here just to demonstrate. So we're merging two columns. It's going to be the same one as before. We call the UDF, merge two columns, and our return type equals an array type. We're going to go ahead and do the same method here though, but we're going to call using the struct type. And as you can see here, we have struct field1, we're going to have as a string, and the second one we're going to have as a float type. So here's the array column expression. We're calling our user-defined function, and we're going to go ahead and provide horsepower and displacement. And now when we do it with the struct version of it, what's returned now, as you can see, here's the array version where we had to keep the same types of data. So we have two floats, and here when we use the struct type, we are able to combine both strings and floats here. Alright, our last examples here, we're going to go into importing and exporting. So this is kind of just a reiteration of some of the things we've already been doing, but just to kind of solidify some very basic fundamentals here. So we're initializing our Spark session. So just to read tabular data, as you can see we've been using in the past, we just have this spark.read.csv, which allows you to import CSV files. So to rename individual columns, we just use the mtcars.withColumnRenamed method, providing the first column that you want to rename, and then the name of the column which you actually desire. So to rename multiple columns, we can just say new call names equals a list of, so we have a list expression here. I'm sorry, it's a list comprehension. So we have x underscore plus x for x in mtcars.columns. So our new call names here. So we've gone ahead and just concatenated this x underscore and then the actual names that existed. So here we just call mtcars.rdd.2df, and then we're going to provide the new column names. So we've been working with CSV files this whole time, but now to work with text files, we're going to say sparkcontext.textfile in camel case, providing the path to the text file. And now just to see the first 5 rows, everything is going to be split up by rows. So we say twitter.take5, and that should go ahead and return the first 5 rows of our text file. So to export the data, we can use the data frame writer module. We're going to go ahead and import that. So before we write the data into the file, we need to coalesce the data into one single partition. Otherwise, there will be multiple output files. So mtcars equals mtcars.coalesce. We're going to set the number of partitions equal to 1. So rather than calling the read.csv, now we're trying to export, so we're going to say mtcars.write.csv. We're going to provide the new name of the file which we want to create, keeping the header equal true so that we maintain the columns. So go ahead and run that. And we get an error. I was so close. Let's see, an error occurred. We got a okay. I already ran this before, that's why I already have the file name saved. So just to reiterate, now we're using the coalesce, which is going to go ahead and make all of the partitions equal to 1, so that we only have one file returned in our export. So now when we run that, I believe, yep, we're going to get another error here. But that's because I've already run this code. So save as text file is the method you will want to use when exporting your data. Alright guys, I hope that these have been some useful examples of PySpark functions and will help you in your project. If you guys have any questions, feel free to reach out and I will be sure to help you. Anyways, enjoy your week and we'll see each other again soon.